I would now like to talk about the qualitative way we look at how stress affects a system at equilibrium. And the concepts that we're going to develop are all grouped together in this notion of something called LeChateliers Principle. LeChateliers Principle allows us to figure out what direction a reaction shifts in, and consequently what kinds of change in the system occur with respect to the amounts of materials as a consequence of some kind of stress occurring. The stresses that we're going to talk about are stresses associated with pressure, stresses associated with concentration changes, and stresses associated with temperature. But in all of these cases, what we're talking about is very simply the idea that I've got something at equilibrium. I have this thing at equilibrium, and then I squeeze down the pressure on that system at equilibrium, or I expand the system so the pressure decreases, or maybe I dump some material in and change the concentration by adding, or I suck some concentration away, or I heat a blowtorch up and I heat up the temperature of the system, or I pour some liquid nitrogen on and I cool down the system. Each of these are ways that I stress that system. Having stressed that system, the question is, how did the system respond? That's what LeChateliers Principle is going to tell us. So before I show you formally what LeChateliers Principle is all about and how it helps us to predict whether reactions shift left or right and what results as a consequence, we need to appreciate stress in general. It always helps to understand LeChateliers Principle if you think about how it is that you yourself respond to stress. So when you think about all the stresses that you face in the world as a student, whether the stresses are from your parents about getting a job in the summer, or from this nagging part of you that knows that if you're going to get into medical school, you've got to get A's in all of your classes, the typical response that we have as human beings is to run away from our stresses. That's the thing we always want to do. And in fact, we have to use like this fearlessness to fight that. But generally, a stress is put on us, we run away. Whether it's just deciding to sleep in or just deciding to go to a party, that's our notion of how you relieve stress. Well, I tell that to you here now because that's how chemical systems respond as well. Chemical systems respond by running away from stresses. So every time you sit and you're wondering about whether or not there's any connection between you and your real world and the chemical systems that you're studying, just understand that the one thing you have in common is the way you respond to stress. You run from it. So, how do you do LeChateliers Principle problems? As I mentioned, chemical systems, unlike you, are not all that capable of doing anything all that interesting in response to stress. You go to parties, you sleep in, you've got lots of different sort of stress relief efforts. Chemical systems, on the other hand, they can do one of two things. They can shift to the right, or they can shift to the left. That's it. That's all they can do. So I'm going to show you these various kinds of stresses that are going to occur in just a few minutes. But when they happen, just understand that as you, as a system, being the system, has to say, do I shift left or do I shift right? So let's follow the steps of what you do as a LeChateliers Principle problem. The first step is an external stress is applied. As I said, that can be pressure changes, concentration changes, or temperature changes. So the external stress is applied. What is it that you do in response? Shift away, either to the right or to the left, from the stress. That's it. That's how you work LeChateliers Principle problems. An external stress is applied. You shift away from it by shifting either left or right. And then look at what results. To the system. If you can follow these three steps, then these LeChateliers Principle problems are incredibly simple. Again, the external stress is applied, you do the opposite, and you look at what happens. So for example, I increase the pressure, you decrease the pressure by shifting left or right, and look at what happens. I increase the concentration of A, you decrease the concentration of A by shifting left or right, and see what happens. I turn down the temperature, well, you turn up the temperature, and then shift left or right to see what happens. That's LeChateliers Principle in terms of problem solving.